Hey everyone, we are looking at the derivative of a product of two functions. So basically you just have two functions multiplied together, hence the name product. So I'm not going to show you where this comes from. If you really want to know, go to page 133 for proof, or you could Google it and find someone else's video. But for the sake of time, I'm not going there. So if you have u and v multiplied together, where u and v are functions, so it follows that u prime and v prime would be the derivatives of those functions. It'd be really nice if the derivative was just like y prime equals u prime times v prime. It's not. We end with this kind of wonky looking thing where it's u prime v plus uv prime. So the derivative of the first times the second plus the first function times the derivative of the second function. So putting it into our ddx notation, add this guy to the list. So hit pause, add this to your list. Do it right now. I'll wait. Okay, I waited. So best way for us to look at this is just to try it out a few times. And I have a suggestion too as you do this. I recommend rewriting that a few times just to like get it in your head. If you just write things a few times, it'll stay in your head better. When you are learning how to do this, a really good idea is to start out just by listing out your u and your v. So u would be x to the fourth. V would be cosine 6x. And then also write out your u prime and your v prime. Because if you have these listed out, it makes it a lot easier. So u prime is just going to be 4x cubed. V prime is going to be negative sine 6x and then chain rule times 6, or negative 6 sine 6x. If you have your product rule written right underneath here, y prime equals u prime v plus uv prime. It's kind of nice actually to have that there your first few times, because that way you can just be like pointing to it going, okay, so for this first guy, I have u prime, that's 4x cubed, I write it down, times v, the cosine 6x, and then plus u, which is x to the fourth, times v prime, which is the negative 6 sine x. Make sure you have a multiplication dot there. So times negative 6 sine 6x. I could clean this up a little bit, but I'm not gonna. I don't really need to. Okay. Example 1, done. Next, we have this f of x equals e to the cosine x times natural log sine x. I have no idea what these functions would look like, by the way. If you really want to know, graph them. But by the way, sometimes when we do these product rule things, if you try to put your derivative equation into your calculator and then compare it to the end derivative, sometimes they don't match perfectly, and that's simply because these are really complicated functions. Okay, so first of all, I'm going to list my u and u prime. And also the same for v and v prime. So first, e to the cosine x is u prime, u. U prime is going to be e to the, keep the inside the same, times derivative of the inside, negative sine x. And then v is natural log sine x. V prime is 1 over, there's my derivative of the outside, while keeping the inside the same, sine x, times derivative of the inside, cosine x. For the sake of less space to write, I'm going to simplify that to cotangent x, since that's what it equals to. That's kind of a bonus step. We don't really have to do that, but it's not a bad thing to do. So then finding our derivative, I'm going to go down a line so I have lots of room to write. So u prime, that first guy, and it's helpful just to point to things as you do it. E to the cosine x times negative sine x, times v, so times natural log of sine x, and then plus u, e to the cosine x, times v prime, which is cotangent x. And I'm done. So no cleanup required. I would rather you concentrate on the calculus than on the cleanup. Of course, as soon as I say that, our next example, we are going to simplify completely, and this one is going to be some seriously wonky stuff. Bear with me on it. And we have good reasons to do it, and namely, it's having the simplified completely. And when I say simplify on this one, it's going to look like complicating, not simplifying. But we'll use that simplified version to find all horizontal tangents, that is, where all the slopes are 0. Because that's something that you sometimes have to do. Okay, so we'll do our usual thing. We have our u and u prime. So u is 6x minus 7 to the 4th, and u prime is 4 times, keep the inside the same, 6x minus 7, new exponent 3, and then times 6, and I'm going to clean this up, 24 times 6x minus 7 quantity cubed. And then my v is the 2x plus 1 to the 8th, and v prime is 8 times 2x plus 1 to the 7th, chain rule of course, and then times derivative of the inside times 2. So v prime is really 16 times 2x plus 1 to the 7th. So now using our product rule here, I'm going to come here so I have plenty of room to write. This is going to be ugly and long. I apologize in advance. Okay, so u prime, actually I'm going to go ahead and write this, u prime v plus u v prime. Just, it's nice to have it in front of you. And also writing it a few times helps you get it in your head. Okay, so y prime, u prime, so the 24 times 6x minus 7 cubed times v, which is 2x plus 1 to the 8th, and then plus u, which is the 6x minus 7 to the 4th, times v prime, which is the 16 times 2x plus 1 to the 7th. Okay, we're going to simplify this, and it is super not obvious how to simplify because it's so long and weird. So let's do an analogy first. Here's my analogy. I replaced all the 6x minus 7s for a and all the 2x plus 1s for a b. If you were asked to factor this, you would be like, oh, okay, 24, 16, the biggest thing that goes into both is 8. And then a cubed and a to the 4th, the largest thing that goes into both is a cubed. And then b to the 8th and b to the 7th, the largest thing that goes into both is b to the 7th. And then our parentheses, and we know it's like this sort of setup, right? So it's this 8a cubed b to the 7th times something to give us the 24a cubed b to the 8th. So I have 8 times, I need a 3. A cubed, I have a cubed in front, I need an a cubed, so I have all the a's I need, but I need one more b, because I have b to the 7th, I need it to be b to the 8th. So I have that, and then same logic, 2 times a, because 8a cubed b to the 7th times 2a gives us the 16, bam. A cubed times a to the 4th, and the b to the 7th is there. So going back to our function here, it's the same exact idea. Let's see, will this fit? It can, bam. I wanted to keep this in sight. So factoring this guy, like looking at the 8 and the 24 and the 16, the largest that goes into both is the 8. And then the 6x minus 7s, I have 3 in the first pile and 4 in the second, so I'll take 3 of them out. And then the 2x plus 1s, I have 8 in the first and 7 in the second, so I can only take 7. And then I like to use a square bracket here just to kind of give myself some visual division. And then it's this piece here in the inside that we're doing. So 8 times, I need a 3 to give me the 24. 6x minus 7 cubed, I have enough. 2x plus 1 to the, I need 2x plus 1 to the 8th. I only have 2x plus 1 to the 7th, so I need another 2x plus 1. So that's like the equivalent of me doing 3b in the original, in that little analogy. Plus 8 times 2 gives me the 16. And then I need 6x minus 7 to the 4th. There's only 3 of them out in front, so I need another 6x minus 7. And just double checking, there's 7 of these 2x plus 1s. 7 in the front, so I have that. We're almost done simplifying this. This is the case of simplifying by way of complicating, I realize. So I have 8 times 6x minus 7 cubed, 2x plus 1 to the 7th, and then cleaning up. I'm going to do this in one step since I'm trying to save a little time. 3 times 2x is 6x. 2 times 6x is 12x. 6x plus 12x is 18x. And then I have 3 times 1 is 3, minus 2 times 7. So 3 minus 14 is negative 11. So this is considered fully simplified because it's completely factored and it's just a pile of things. Now we basically just have some stuff multiplied together. If we're finding horizontal tangents, that means the slope is 0. If the slope is 0, that means that if you have things multiplied and something 0 for the answer, it means one of those things has to be 0. So the 6x minus 7 is the 0, or 2x plus 1 is 0, or 18x minus 11 is 0. This is what will give us the horizontal tangents. So solving for x, we get 7/6, negative 1/2, and 11/18. So you will see problems like this. You will be tested on this. And I know it's kind of algebraic hell, but that's okay. It's good for you because it's building character or something. I don't know. Anyway, there is our product of two functions.